Hey, Algebra 1. I am going to go over the first day's lesson. This is CW 7.1, Introduction to Quadratic Functions. What I'm going to do is I'm actually going to start on the second page. So if you guys want to flip to the second page, I'm going to go over the notes on this back page. Some of you guys had it, some of you didn't. Okay, so what we're going to do is we're going to examine this tile pattern here. And you see that we have figure 1, we have figure 2, and figure 3. Okay, so what we need to do is first figure out what is figure 0 and what is figure 4. And how many tiles do they have? What do they look like and how many do they have? So maybe pause the video and look to see if you can figure it out. Okay, now to figure it out, well, let's first count how many there are in each one. Well, I know here I've got 3 tiles, 1, 2, 3. And then here I have 6 tiles. And then here in this third one, I've got, let's see, this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. That's 11. Well, let's look and see what is the change from each one, from 1 to 1. Say from the 3 to the 6, the change is plus 3. We're adding 3. Then the change from 6 to 11 is plus 5. Well, you notice that that change doesn't stay the same. It's not plus 3 on the next one. It's changing. So that means it's changing at a certain pattern. And it seems to increase by 2 each time. So then this won't be plus 5, this will be plus 7. And that means that the first one increased probably plus 1, because there's a pattern. 1, 3, 5, 7. Plus 1, plus 3, plus 5, 7. Okay, so if the first one increased by 1, then that means it had to be 2. And then the last one, figure 4, it went from 11 and added 7, so now it's 18. So now let's look at the figures themselves. First thing we want to look at is, well, now we want to know, now we know how many tiles there will be, but what do they actually look like? Well, first let's see if there's anything that doesn't change, something that's the same. And I noticed that the top 2 blocks, they stay the same for all 3 pictures. So that probably means that all of these will have that same 2 blocks. This will have 2 blocks for figure 4, and then this will probably have 2 blocks for figure 0. Well, for figure 0, the number says 2 blocks, or 2 tiles, so that means these 2 tiles are all I need. Now for the last one, well, obviously it's going to be some square that hangs off of these 2. I can see that because there's a square here, and then there's a 2 by 2 square here, a 3 by 3 square here, and a 4 by 4 square here. Well, I know that this has 2 at the top, again, and this is a figure 4, so this will be a 4 by 4. I know that because here there's 3 again by 3 because it's figure 3, and then this is figure 4, so it's a 4 by 4 square. And there's those 2 squares on top again. Okay, so now let's fill in the table. Okay, so the table, our first one was figure 0 and we had 2 tiles. Then for figure 1, 3, figure 2 had 6, figure 3 had 11, figure 4 had 18, but then how do I figure out the next ones? Because we don't have a figure 5, 6, and 7. Well, let's look at the pattern again. Okay, so the pattern again was 1, 3, plus 5, plus 7. So let's write that pattern here. Plus 1, plus 3, plus 5, plus 7. So that means the next one must be plus 9. And then plus 11, then plus 13. And that's the change that we're going to have. So now 18 plus 9 would be 27. 27 plus 11 would be 38. And then 38 plus 13 would be 51. Okay, so now the question is, are the number of tiles increasing at a constant rate? Well, constant means that the rate never changes. The rate is the same every time. But the rate is not changing. I mean, the rate is changing, because here it's 1, then the rate is 3, then the rate is 5. The rate's constantly increasing, but it's not constant, it's not the same, so no. The rate changes. Okay, now what does this say? Now this says, what do you notice about the second rate of change of the tiles? Well, the second rate of change again is what is happening to the actual rate of change. Well, from the first one to the second one, the rate of change increased by 2. From the second one to the third one, it increased by 2 again. Then from the third to the fourth, it added 2, and then so on. It keeps going. It's adding 2. So that means the second rate of change is that the rate of change increases by 2. Okay, so now it says draw a sketch of figure 100. Determine how many tiles are in figure 100. Well, I already know that in looking at my previous drawings that all of them had that 2 squares on the top. They've got 2 here, 2 here, 2 here, 2 here, 2 here. They all have that. Okay, so let's start with that. There's my 2 squares, and I'll highlight it blue. Okay, so now I got to figure out, well, what's the size of the square? Man, remember it's a sketch, so it doesn't have to be perfect. Figure 100 probably has lots of tiles, and there's no way I can draw that many. Okay. Well, for figure 100, if we go back to the other pictures, again, if this was figure number 3, then it was 3 by 3. Figure number 4 is 4 by 4. So the figure number tells us how wide and how long. So that means that this is 100 by 100. The second question is how many tiles is in that figure? Well, I know that if I multiply 100 times 100, that will tell me how many are in the box or in the square. And then what I need to do is add 2 because of these 2 small tiles. So 100 times 100 is 10,000 plus 2, 10,002 tiles. Okay. So now the next question is draw a generic sketch. So they want a generic sketch for any figure in the tile pattern figure X. So we want to draw a sketch that could represent any figure number. Okay, well, we always know that there's going to be 2 at the top. And then we always know there's going to be a square down here. So we'll just kind of make some lines here. Okay, there's our square. Uh-oh. Disappeared on me. Okay, there's our square. Well, the width, we always knew that whatever the width is, or whatever the figure number is, that's our width. So this was figure 100, so the width is 100. So the figure number, we're going to say the figure number is x, so if figure number is x, then that side can be x. And we also know that the other side is the same, is also the figure number x. And don't forget, we still have our little box of 2. So now the question is, how can we make an equation using these variables? Where the number of tiles is y. Well, I don't want you to write y, I want you to write f of x. Because remember, f of x is the same thing. So we write f of x, and remember when we write an equation, we write equals. And to write the equation, let's think about how we found the number of tiles here. The number of tiles here was one side of that square times the other side of the square, 100 times 100, and then we added the 2. Well, here, then that means this would be x times the other side, x, plus that same 2. And then we can simplify this, because x times x is x squared. And there's our equation. And if you notice, that 2 never went away. That 2 is always there. So don't forget about it. Okay? So now, the question is, use this equation to determine how many tiles there would be in figure 57. Okay, well, we could simply just use the equation by setting it up. Do f of x equals x squared plus 2. And then we're going to plug in that 57. Because plugging in the number should give us how many tiles there are for figure 57. So now I'm going to plug in 57 where there's an x. So that's here. F of 57. Plug it into my calculator. I get 3,249 plus 2, which is equal to 3,251 tiles. Okay, so that's how many tiles there are. Okay, so now let's look at this next one. So Carly found a rule for y equals x plus 2 for the tile pattern in the problem number 2. Does her rule work? Okay, well, let's test it out. I know that when I plug in 57, like up here, that I'm going to get 3,251 tiles. So if Carly's rule works, that means when I plug in 57, plug it in for the x, that I should get the same number. So now 57 plus 2, 59. And then let's do 59 squared. I'll pull up my calculator here. 59 squared is 3,481 tiles. And that is not the same as what we found with the rule that we made. So that does not work. This is correct. So her tile pattern does not work.